Hello everyone. Let's continue with the previous topic. We'll visualize the data in this video. We'll start with histograms. Let's plot them between position and points. First, create the subset of data frame. We'll start with adding a code cell here. We'll name the data frame as P equals to. We'll create the subset of data frame with the following columns that are position and points. And will not consider the combination of positions. So we'll create a list of positions that we consider and pass it to the easin function. We'll create a list named positions and we'll specify the positions we actually want, that are C, PF, SF, PG and SG. And now we'll pass this to the easin function. We'll first call the data frame P equals to P of the column name position dot is in positions. It will only consider the positions that are mentioned in this positions list. And now we'll print this. Let's run this cell. You can see you have positions column and points column here. Now let's see the histogram. Hist is the built-in function of pandas we use to plot histograms. We'll first call the data frame here P and the column PTS dot hist by equals to P of POS. Here we are defining the data frame first, then the PTS column, and then we are going to use the built-in function hist, and we are going to make several histogram subplots based on POS, that is position. As we have 5 positions, we'll create 5 separate histograms. So we'll run this and you can see that 5 histograms are built here. And you can change the layout. You just need to specify layout and then mention the tuples. Let's see. We'll copy the same code and paste it here. We'll add the layout option and we'll set the layout to 1, 5. And we'll run this. See, this creates or this plots histograms in the form of 1 row and 5 columns. So here are the histograms, and you can also change the dimensions by customizing fixed size options. So let's paste the same code here and layout is 1, 5 and fixed size is 16, 2. Now run this. So here it is. You also change the dimensions. Now you can also do the same thing using seaborn. First, you need to import seaborn and matplotlib. So we'll import them. Import seaborn as SNS. Import matplotlib dot pyplot as PLT. We'll now use facet grid module of seaborn, which will create multiple subplots that takes 2 arguments as input, where one is data frame and the other one is the argument specifying based on which the multiple subplots will be created. In our case, it is position column. So S equals to SNS dot facet grid, and we'll pass the data frame here and call equals to position. And then we'll use map to plot s.map tlt dot hist and pts. Now let's run this. You can see the grids here. Now let's move on to box plots. So here we are going to use built-in box plot function of pandas, and as arguments we are going to define column equal to PTS and by position again. Each position will be given its own box. So P dot box plot column equals to PTS and by POS. Let's run this. Here you go. Each position is given its own box. P, PF, POS, PG, SF, and SG. We can also do this using seaborn. So as we already imported seaborn, we use the boxplot function and the arguments are x equals to POS, y equals to PTS, data equals to P data frame. So SNS dot boxplot x equals to POS, y equals to PTS, and data equals to P. Let's run this. See, this really looks good, right? Now, if you also want to see the individual data points for each of the box, we'll use strip plot function and in arguments, we'll set jitter equals to true so that points are not superimposed if there are multiple points in that same position. So it helps in moving out a bit. And we set alpha transparency of 0.8. Alpha takes a value between 0 and 1 where 0 means completely transparent, that is invisible, and 1 means completely opaque. By default, alpha is set to 1, which means data points are fully opaque. We'll copy the same code here and paste it here. Then we'll use strip plot function, sns dot strip plot, where x is POS, y is PTS, data equals to P, and we'll set jitter equals to true. We'll set the marker as O and alpha value to 0.8, and finally we'll set the color to black. Now let's run this. Now see, it looks like this. We see actual data points on top of box plot. Now let's have a look at heat map. We pass correlation matrix as an argument to our heat map function. So first, we are going to compute correlation coefficient matrix. Let's create a variable COR equals to data frame df is used to compute the correlation. So df dot the correlation function. And let's see how the matrix looks like. Now we got our correlation matrix with pairwise correlation. And this is Pearson's correlation coefficient, which is linear correlation between two variables, ranges from -1 to 1, where -1 indicates a perfect negative correlation, 0 indicates no correlation, 1 indicates perfect positive correlation, and the rest values accordingly. you can see that the age and age have one correlation, which is the perfect correlation, and age and G has 0.06, which is a positive correlation. And we can see that the matrix is symmetric. That is, the values below the diagonal are equal to the values above the diagonal. That is mirror image of one another, as they have same pairwise correlation coefficient, which means that x1 and x2 has same correlation as that of x2 and x1. Now let's make the heat map using the heat map function, and our correlation coefficient matrix will be the argument. SNS dot heatmap COR. Run this. This will give us a heat map of intercorrelation matrix of each variable with one another and a gradient scale. And you see that white color here at the diagonal having correlation coefficient of 1. You can see from the gradient scale here, if it is darker color, the correlation is low, and if it is the lighter color, the correlation is high. If the color is red, the correlation is about 0.5. If you want to adjust the figure size, then we'll have to use subplot function here. So fig first fig ex equals to plt dot subplots, and we'll set the fig size equals to 7,5. And we are going to make a heat map as a square. So we are going to say square equals to true. So, I'm sorry. Let's first add this SNS dot heat map, and we'll pass this COR, and square equals to 2. Now run this. Notice that we have a square heat map, and now the size is also adjusted. Now let's see scatter plots. We are going to select columns that have numerical data types for this. We use select data types function with argument include number, which includes columns with numbers only. So df dot select d types, and with the argument include equals to only number. We are going to assign it to a variable. We'll assign it as data2 equals to df dot select d types, which include only number. Let's see how it is. We'll just print this data2. You can see here. Now to select the first 5 columns by index, we use iloc, where iloc means index location, and we specify the range of columns and rows there. So data2 dot iloc colon comma colon 5. The first value here is colon, which means that we are going to select all the rows, and then we are going to give a comma, and then colon 5 means we are going to select columns 0, 1, 2, 3, 4. That is the first 5 columns. Now run this. So here are the first 5 columns. And to select columns based on the column names, it is just like we selected positions. We create a list of those 5 column names that are to be selected first. So first we'll assign it to a variable list. Selections equals to, we'll specify the column names age, G, STL, BLK, AST, and finally PTS. And then we pass this to the data frame. So we'll create a new data frame here, df of 5, that is data frame of 5 columns, and df of 5 equals to, we'll call the data frame and pass this list of selections here. Now we'll print this, df of 5. Let's run this. See, this displays the data of only these 5 columns. Now let's make the scatter plot using seaborn. We use pair grid function here. So G equals to SNS dot pair grid, and we'll pass the data frame as the parameter df of 5, and then we'll use map to plot, G dot map plt dot scatter. And now let's run this. This actually takes some time, so let's wait until it's run properly. Yes. You know, we see that this creates the scatter plot grid for the first 5 columns, age, G, STL, BLK, AST, and PTS. We notice the perfect line here, which means that the columns are compared with its own column. So it is a self-comparison x1 and x1. So congratulations, you have done some basic exploratory data analysis. Try to apply this block of code to your data set of interest. Before going to the next video, let's see few methods where EDA is majorly performed. The first one is univariate analysis. Uni means single and variate means variable. So here it is analysis of single variable. When you have a data set, each field is called a variable. Suppose here PTS is a variable, AST is a variable, and each field is a variable. An analysis of each field, that is each variable separately, is called univariate analysis. It provides summary statistics for each field in raw data set. You can do that using BoxPlot and many more others. And when you analyze 2 variables at a time, it is bivariate analysis. It is performed to find the relationship between each variable in the dataset and the target variable of interest, or simply using 2 variables and finding relationship between them. And if you analyze more than 2 variables at a time, then it is multivariate analysis. It is performed to understand interactions between different fields in the dataset, or finding interactions between variables more than 2. We'll see each of them in detail in coming videos. Bye.